use red to simulate dirt, black to simulate asphalt, white to simulate snow, blue to simulate ocean, and gray to simulate a rocky earth.
Our data collection acquisition process is all of our data collection was at night. We used a shot line to simulate the sun. This shot line was placed a meter away from the center of the turbine and at the top of the flame. What we also did was we angled it down at a 45-degree angle to give us the maximum amount of heater we reach each flight out. This way there would be a lot of motion on the ground here, just strong data about the collection as well as direct solar readings. This is our wind turbine. As you can see, there are 6 solar cells on 3 blades with 2 cells for each one. Each of the cells voltage is red ESP32 on the middle of the turbine. To prevent the need for suffering or weighted data off, we have ESP32 and power on board the turbine. So and when we use Bluetooth on another ESP32, which does all of our data acquisition. As you can see, when I press this button, the turbine spins, which simulates the turbine. The red LED, as we change the colors on it, simulates the different colors of the pitch values of the turbine that the solar cells can use. So after we get the data from the on board, it's going to send Bluetooth to this guy. This guy's going to do all the data logging and analysis. So come over here. This is the MATLAB UI that we made from the ground up. Here I can select the proper COM port. This one's going to connect to the ESP that is not on the signal. And if I go to the data tab, I can see all the data being populated here. So as James spins the turbine, I have the data recorded here, but then I can go over to plot, and I can pick any one of these, and then if I plot it, click update, I should see a nice little sine wave right there. This is how we did our data acquisition. Once we're done, we can go ahead and come back over here, we can click quit, we can type in whatever we want our Excel file name to, we can click export, and over here. So here we have a little app that helps us see the data a little bit better, a little bit quicker. So if you see on here, we have every single solar panel as well as their voltage values. Right now they're pretty low because we don't have the shot light on. So once we switch that guy on, you'll see that all the voltage values seem to spike pretty well. And this app also connects straight to this Google Sheet. So we'll have a QR code up where you can monitor this at your own house, at your own home. And then again, you can control the on the pitch, just move and use the LED on the.
All right, so next we'll go to Honda, and this is the second and third place for the Honda in Eclipse Challenge.
So second place goes to Banana Bread, and third place goes to Certified Professional. So if you guys are here,
raise your hands. Nice, guys. And first place for the Honda in Eclipse Challenge goes to Runtime. Do we have Runtime here? Yep, thank you, guys. All right.
Hey everyone, this is Team Runtime, and our project for MakeOHI for 2023 is Intuit. So first, what's our motivation? It is to aid the visually impaired people in their day-to-day lives so that they can enjoy the beautiful world of the list.
We do it all inspiration from a friendly neighborhood pilot whose goal it is to help those in need. And we decided that Intuit would be a step to giving them these spidey senses that he has, and maybe not just them.
So Intuit is an obstacle detection platform that uses TOF sensors to detect obstacles in someone's environment and then provides haptic feedback to the user so that they can stay safe while moving. This is a very accessible solution because not only is it low power, it's also low cost and can be DIYed by anyone with commodity hardware now that we've open sourced our code. It's also very versatile because it has way more use cases than just being used by the So the eyes of our project, the crux of our project, are these TOF sensors that are mounted in 4 directions on a borrowed chef's hat as a hat for now. But these sensors are accurate up to 4 meters and can alert a user about an obstacle in their path. We chose these sensors over a camera, firstly for privacy reasons, and secondly for their low computation and power costs.
Here's a quick demo we walk around in human content tubing. It may look a little rough around the edges, but I promise you it's being very insistent that there is no obstacle in my path, and as you can see here, it helps guide me towards the safer path. Next, we will also see how MakeOHI alerts me to these obstacles. These vibration motors or the haptic feedback is fed to me through 6 motors mounted to my body. The idea behind this is that we can alert users to obstacles at their head, at their chest, and down below near their feet. All of this computation is done by a low power Raspberry Pi Zero, and again, it maintains the low cost approach to this whole solution. Next, we have the arm-forces approach. Well, we talked earlier about how it has myriad use cases, and think about eyes on the back of your head. Well, MakeOHI has a sensor mounted to the back of your head that could alert an individual to an incoming potential threat, thus increasing a soldier's awareness in the field.
The spidey senses.
MakeOHI uses a power bank, so it does not require a power bank to be mounted to you. Given that everything is so low power, this solution could be fit with baseball cap, and you would walk around and no one would be the wiser. The vibration motors we found are the most ideal solution as they do not interfere with your senses and can be more easily accustomed to. Some of the challenges we faced, however, was scaling the solution. As you saw in the previous slide, we have the solution mounted to an entire t-shirt with a little bit of ducting. But we hope to be able to scale this down in the future and do not see this as a concern. Next, how many sensors is too many and how many is just right? We chose 4 for the main 4 directions at the moment, but we intend to grow this as a potential approach. Finally, it is translating a 3-dimensional world to 2D haptic feedback, and this was the major challenge for us.
So what does the future for MakeOHI look like? Firstly, we want to reduce the complexity that we just saw on Park's t-shirt, so that this whole system can fit, like he said, inside a baseball cap. Everyone's very used to wearing caps, and it's a very on and off system that can easily be used and put aside when you reach your destination. Next thing, we want to make DIY kits so that these systems and these platforms can be very easily used by anybody and can be set up with your friends. And the last thing is increasing the sensors on the system so that we can accurately detect any obstacle in any direction more better than we do now.
So well, that's MakeOHI, making mobility more accessible to everyone. Thank you.
Congrats again, Runtime.
Now we'd like to call upon stage Hans to introduce the winners of the Intel Challenge.
Hey,
All right. Thank you, everyone. Good afternoon. I'm sure it's been a long 24 plus hours for everyone, but really appreciate all of the hard work all of you guys have done. We can go ahead. Yeah, we're showing them already. So our second and third winners are team numbers 31 and 53. So that's charging guard and the cooling vest. With the cooling vest, we thought we really like this idea because that can be one of the a potential big issue in the fab. You know, keeping cool while you're working, especially technicians when they're doing maintenance type activity. And then the charging guard, this potentially can be reduce the safety when you're working around certain type of equipment. We kind of looked at it both ways. One, potentially if you're around the equipment with high voltage, this can potentially prevent if you got shot, and also it can also alert you to a potential danger as well. Okay, so those are the second and third place. We'll move on to the. So the first place was let's go ahead and watch the video first, then I can make some comments.
So this is a presentation of our clean room garment redesigned by Keen Darkins, Carl Lemhart, Michael Jordan, and Andy Yates. So the first problem we identified were tears at the seams. One of the largest complaints was the frequency of tears that cause contamination when working with hand tools or getting caught on instrumentation. And the only way for the worker to identify tears is through inspection or inspection by peer. And this poses a contamination hazard and reduces the worker's efficiency due to time spent checking for tears. So our solution is wired seams. The area around the seams will be made of mesh material that sends power once per minute, just like a pulse. And if the circuit doesn't complete, the suit will detect the tear and prevent contamination. And a waterproof device will be built into the wrist of the garment. So this is our example solution. Here, the simple representation of a wired seam system. Several circuits will be wired through various limbs. If a tear occurs, the user can quickly identify which part of their suit is damaged. The green light indicates a suit in good condition. Red lights indicate tears. Okay, so here's the implementation of this. Since the microcontroller is simply stitched in the material, the component can be easily upgraded over time as new needs arise. And washing suits won't pose a risk to the microcontroller. It's going to be waterproof. And in case of any malfunctions, it's a very simple system, so it can be easily replaced. And standard suits can just have wire along the seams, but highly sensitive clean rooms can be stitched with wire mesh all throughout the fabric rather than solely at the seams. So for example, the Gore-Tex suits. Second problem we identified was that the boot covers slide down. So when we're wearing the current boot covers, the components slip down, requiring users to stop work and pull them up. And this is due to the poor drawstring mold that does not provide a strong fit. And the downward laminar airflow in the clean room also just fills them with air and forces them to slide down. And this creates hazards, can cause snags or falls and tears. So this is our proposed solution.
Oh no, my boots are falling down.
The user will select from a range of sizes, from small to double XL. First, they will zip in the lower boot part to the upper pant leg. Once fully zipped, they will cinch it together to tighten it and reduce billowing. This will eliminate the problem of the boot cover coming down due to only having one method of securing it with the elastic loop. So the pants will have multiple vertical layers of zippers to ensure they're being adjusted for different heights and increase accessibility. The zippers will be secured in place before you enter the clean room, so it'll be unlikely the worker will have to attempt to re-zip before putting on the restricted gloves. Users won't need to bother with buttons or hard open clasps in the clean room. Third problem we identified is when talking to coworkers, the user voice gets muffled, and it's human instinct to pull down the mask, which can cause contamination as a lot of particulate comes out of the mouth. So our solution is a clear face mask with filtered vents on either side, allowing for visibility of the mouth while ensuring breathability of the user and audibility of speech. And at the nose will be a metal nose clamp piece, allowing for a tight grip and reducing fog on the glasses and the goggles. And this new face mask will be connected to the hood, and users will be more likely to keep their mouth covered in position for the whole shift, and the tighter seal will reduce particulate. So this is our final prototype. It was decided to, we fixed the big three problems that were pointed out the most by the fab workers. And this is only a concept solution because we don't have materials to actually construct. But the added wires in our microcontroller system won't be expensive to implement for disposable suits because the wires only have to be connected to the suit, and battery packs can be manufactured to provide power to the wires. And a zipper connecting the boots to the pants means the boots won't fall down, and the proposal design will also solve the issue of the contamination from users pulling down their face masks to communicate. And those will require a simple hood redesign.
So first, yes. So just some comment on that, actually really one comment. Team 14 here, those are sort of the three main areas where there's potential, I'll call it failure points, right? The boots, where it kind of overlaps the suit itself, it somehow gets ruptured, torn, whatever. And then up in the hood area or the facial area, right? Team tried to touch on different ways to try to mitigate that or potentially prevent an exposure of the clean room. So those were some of the things that we really liked about this group. Thank you again.
Thank you, Hans. All right, now we go into our general prizes. For fifth place, we have SEAL Team 0. For fourth place, we have Artemis Sar.
For third place, we have the Cool Beans.
Hey everyone, this is the team of the Cool Beans at MakeOHI 2023. I'm Brett Schaefer, a second year CSC major, and the rest of the team consists of Sawyer Ramsey, second year CSC major, Garrett Norman, second year ISC major, and Josh Wolf, second year ECE major. I'm going to pass it off to Garrett and Sawyer to talk about our project this year.
At MakeOHI 2023, our project is a demonstration of our goal to bring more energy and cost-effective heating and cooling to homes. We built a mock house that contains 2 separate rooms with features to maximize our goal. It contains 2 heating pads at the bottom of each room, simulating radiant floor heating. The tubing system with fans and ice water to simulate chilled water air conditioning. An automated window system, a through-wall ventilation fan, and a rotary sensor to identify the wind direction. All of these features allow complete control of the temperature of the environment in the best way possible. Want to cool down one room? The system will choose the best way to do it as cheap and efficiently as possible. For example, if outside is colder and the other room is hotter, it will open the window and shut the fan. Want to warm up only one room? Then the system will turn on the heat in only the desired room if the other room is colder. If a room needs to be cooled and the outside temperature is cold with a cross breeze, the system will open the window to create an effective draft. Instead of making each of these decisions ourselves, our goal is to have the program decide to do the best possible solution based on the desired temperature requested by the client. However, in just 24 hours, this is a little ambitious. So we have created the functionality of each aspect, but it still requires manual input. The temperature display is shown using a simple Python GUI with each situation to showcase the functionalities and how they work. Looking at existing smart AC systems, they estimate saving users between 10 to 25% on costs. With our hyper-efficient project using AC and heating as minimally as possible, we are estimating saving our users 20 to 30% on total costs. How does all of this work? All the sensors used, temperature, photoresistors, and a rotary encoder, are read to the Arduino using its analog inputs. Once read, we send the information over to the Raspberry Pi using a serial connection. Based on the given information and pick scenario, we control the fans, servos, and heating pads that are all operated using the Raspberry Pi. The main program allows customized use of our program scenarios with the hardware to simulate our project inside the mock house.
The included features of the mock house is a fan that allows air movement between the 2 rooms, 2 controllable windows, heating pads in the base of the floorboards, a flap that allows isolation of 2 rooms from one another, and 2 AC units on the outside of the mock house. In this clip, we are demonstrating a situation where you want to cool your house down while it's cold outside at night, for instance. Here, we are opening both windows and turning on the fan to get a draft blowing through your house so you do not need to use air conditioning. In this scenario, room 1 and room 2 are much hotter than the outside of the house. So we close off and isolate room 1 from room 2, and then exhaust all the hot air out of room 1 to cool down where we're currently at. This clip demonstrates a simple use case of the program. The program automatically opens up both windows on a nice morning to let in that nice cool air. The next steps we'd like to take with this project are to develop an interface for ease of use. We would also like to integrate the Home Assistant, which is an open source home automation program. A final thing we would like to do is create presets per person and a way to identify each person in a given room. This way we can dynamically adjust the room for the people inside the room.
Congrats, Cool Beans, on getting new Apple AirPods.
Hey everyone, this is the team.
Now, we go to second place. Second place, we have Banana Bread.
Hey, what's up, MakeOHI? This is Eric from Banana Bread, and we're excited to share the project with you. We stayed up till 5 a.m. working on it. So it's quiet hours, but that doesn't mean we're any less excited to show you.
3 bots, 1 arena. Garrett, Toaster, Felix. 3 robots enter the arena.
These are not robots. They are safety bots. Made to be the future of transportation safety, each robot represents a car in the real world. By giving each car cheap and efficient communication to cars nearby, our software can share position, rotation, and velocity information to predict and prevent future accidents.
At the very top of our project is a camera, which is supposed to represent a GPS in the real world, but we don't have cars and actual GPS circuits to use, so we use a camera to represent GPS instead. And we use fiducials, or QR codes, basically, to track our cars around the floor. And by processing the image from the camera, we can figure out where every single car is, get its position, rotation, and calculate its velocity over a longer period of time. We can then send all of this information to every single one of the cars, so the cars know where each other are, just like they would in the real world with this system.
In order to prevent our cars from hitting each other, they need to be able to communicate. And ideally in the real world, this would be done with radio. But because that's a lot of work and we're just working in a small area, we opted for a Wi-Fi network instead. This is the heart and soul of our network. This is the banana bread Wi-Fi network on the little Wemos. And on each of the cars, Wemos, and there is Python scripts on each of the computers, yes, and on the controllers here that can communicate directly with the bots through interfacing with the custom DNS we built on the banana bread. So finally, we have our representation of the car. These are tiny little Wemos powered, I guess, human-controlled vehicles that we use as the substitute for our cars. It took a bit of working to get these connected to everything. The main issue was getting them into a form factor that looked and felt like a car, so that we could actually simulate the real life scenario. We started off by drawing out a circuit diagram. This would be basically everything that would drive just the main motor itself, without rotation, which we handled with a servo at the back of the vehicle, because our first prototype, we ended up putting the motor the wrong way, and we decided to just stick with it because it was easier than undoing all of the hot glue that we had used as insulation and redoing the other robots as well. So we have front-wheel drive with rear-wheel drive steering.
All right, to sum it up, it's a small start, but I think that implementing this kind of crash detection in the real world can really help increase the safety on our roads.
There was so much excitement throughout this event. Thank you to the organizers and the sponsors. We are so much very excited to see you again at MakeOHI in the fall.
Congrats, Banana Bread, for winning a Nintendo Switch Lite. Now we go on to our first place prize. All right, for first place, we have Mediocre Amateurs again, winning Xbox Series X.
Our team chose to take on the idea of collecting unharvested LEO radiation and turn it into a practical thing.
But yeah, do we have Mediocre Amateurs here? All right, they might be online. But yeah, congrats, Mediocre Amateurs, for winning MakeOHI 2023. Now, going to our next announcement.
After participating in MakeOhio, showcasing your project can be a great way to share your hard work and creativity with the others. A successful showcase can help you build your personal brand, gain recognition for your efforts, and even lead to new opportunities. To do so, we want to invite you to apply to Show Ohio, which is a showcase highlighting outstanding innovative technologies developed by Ohio State students and alumni. The QR code should take you to the Show Ohio page if you guys want more information about it.
Yeah, in some closing statements, we want to ask you guys, what are your favorite parts about Make Ohio? Anyone? The food, hardware, teams. But yeah, no, we just want to congratulate all the participants on really, really good projects. The judges loved all of your projects. They are industry professionals who have been working throughout and have judged projects like this for the past like 5, 10 plus years. So yeah, congrats on a job well done. We look forward to seeing you create what you create in the future, and we hope MakeOHI 2023 has been an unforgettable experience for all of you. So yeah, thank you for being part of this amazing event, and see y'all at the next Makeathon.
Do you want to call the winning teams?
So before we go, we want you to follow our Instagram, and also we would like to take pictures with the winning teams. So if you guys come down, we'll take some pictures, and yeah.
Also, if
Also, yeah, one more announcement. If you guys borrowed hardware from eClub, we would like you to return that to eClub in front of the clock. Thank you. We take pictures here?
Yeah.
Yeah, yeah.
Thank you so much for everybody who joined us online. I really appreciate it. We are going to go ahead and stop recording and then stop the Zoom call. Feel free to follow up on our website, and if you award one of the winning teams, we'll reach out to you via email.